So it is recording on this computer. So look at the first question, guys. I might give you a curve and ask you, what do you think of the shape of the curve? Is it normal, skewed right, left? You can agree with me that this is not normal, because normal, it has to be symmetric. It looks like there is a tail toward the right. So this is a skewed right curve. Now let's look at the second question. The weight of 2-year-old Hyraxes is known to be normally distributed with a mean of 2,200 grams and standard deviation of 365. If I give you the mean and the standard deviation and ask you to select the normal curve that pertain to this mean and standard deviation, you want to select this one. Why? Because it has the mean, which is 2,200. And if you move one standard deviation to the right and another one, you just add a 365 each time. So this is 2,200 plus 365. This is another 365 and then another 365. On the left, guys, you have to go below the mean. 1 standard deviation below, 2 standard deviation below, 3 standard deviation below. And if you go 3 standard deviation below the mean, 3 standard deviation above the mean, you cover almost 100% of the data set. The second question, he says, shade the region that represents a proportion of Hyraxes who weigh more than 2,930. You can see, guys, more than 200,930. I just shaded this one right here. If I give you this question, let's say on the test, and I ask you, shade the area less than 1470 for Hyraxes that weighed less than 1470. You just go here and shade this one, or select it if it is a multiple choice. C, suppose the area under the normal curve to the left, to the right of x equals 2930 is 0.0228. So he's telling me that this area is 0.0228. How do I express this in simples? When you go to the right, that means you're going greater than. So to the right of 2930, guys, means x greater than 2930. And this probability tells us it's 0.0228. So there is no work that you need to do. It's just a way to write the answer. All right, so this is number 2. Number 3, change into the x values to z-scores. The SAT is an exam used by colleges and universities to evaluate undergraduate applicants. The test scores are normally distributed. In a recent year, the mean was 1475, and the standard deviation was 308. Okay, he gives you test scores and he wants you to change them to z-scores. I'm just gonna pick one of them and change it to a z-score. Here's the formula for z-score. You know the formula is x minus mean divided by standard deviation. So let's take this x value and change it to a z-score. If x equals 1930, z equals, you put 1930 first, you minus the mean, which is 1475, and then you divide by the standard deviation, which is what we put 308. Okay, you can use your calculator here. So that will be 455 divided by 308. And let me just use the calculator to find the answer. 405 divided by 308. It's one. Usually z-scores, guys, written to 2 decimal places, so that's 1.31. Okay, and then you do the same thing for 1340, 2150, and 1450. But let's see the question in part B. Determine whether any of the values is unusual. Do you guys think that this value is usual or unusual? What do you guys think?
Isn't it unusual?
Why?
Because it's below 3.
Unusual if it is bigger than 2 or less than -2. If the value is between -2 and 2, it is usual.
Okay, thank you.
So 1.z equals 1.31 is usual. And let me remind you guys what unusual means. Z is unusual if Z is greater than 2, or Z is less than -2. And if you get the value, guys, greater than 3, it's very unusual. Less than -3, very unusual. All right, now we're coming to probabilities. So we're doing section 7.1 now. Find the area of the indicated region under the standard normal curve. Well, he gives you the area. He wants you to find it. He gives you the lower bound and he gives you the upper bound. What I'm going to do is I'm just going to use calculator. I'm not going to show you how to do the work by hand. It's just time doesn't permit. So I'm going to lobby for the use of technology. So in order to find normal probability, guys, there's only one feature on this calculator. You go to second distribute, and it's number 2. All probability questions can be done using number 2 here. He wants a lower bound, he wants an upper bound, mean, and standard deviation. Well, the lower bound, guys, as you can see, it's -0.445. Upper bound is 2.11. And when you work with Z, this is Z. When it puts 0 in the middle, it's 0 and 1. So it just puts 0 for the mean and 1 for the standard deviation. And you get the answer. And the answer, guys, is 0.6562.
Hey, Professor.
Yeah.
Could you show me how to get to that, like again?
Second, and
Second, distribute.
And normal CDF right here. It's very important formula, guys. You can do most of chapter 7 in section 8.1 under this formula, normal CDF. You're gonna see that. So watch me doing the work and you're gonna see that. Find the area under the standard normal curve to the left of Z equal 1.5. Okay, let's draw the normal curve. And this is Z. This is 0 always in the center. This is 1.5. And to the left, guys, means less than. Okay, let's use the calculator for this one. Okay, so what would be your lower bound? Your lower bound, guys, is the starting bound of the area. As you can see, this tail does not end from this side and does not end from the right side. So what I tell students to do, when your left bound is the left tail, you just use -1 million, because that's going to extend for infinity. In the calculator, it uses -1 with 99 zeros, but we're just going to put -1 million. And here is the negative sign right here. Upper bound, guys, is this value right here, the one that he wants, 1.5. And then 0 and 1. And here you go, that's the answer. So the answer will be 0.9332. That's the area. Okay. Number 6, find the area to the standard curve to the left of Z equal 1.25. It's the same question, guys, but different number. So -1 million stays, but instead of 1.5, I'm just going to use 1.25. And look how simple it is. So if you want me to write what I did here, normal CDF. Always when you do a left area, you start with -1 million. Then you put the upper number, which is the 1.25, and then 0 and 1, and that will give you 0.8944. Okay. Number 7, guys, he gives you the upper bound and the lower bound. He says Z between 0 and 2.25. So you just do normal CDF, 0, 2.25, comma 0, comma 1. And let me show you. Second distribute, normal CDF, 0 is the upper lower bound, 2.25 is the upper bound, and 0, 1. And the answer is 0.4878. 8. The distribution of cholesterol levels in teenage boys is approximately normal with a mean of 170 and sigma is 30. Levels about 200 warrant attention. If 95 teenage boys are examined, how many would you expect them to have a cholesterol level greater than 225? In order to answer this question, guys, you have to figure out, first of all, what's the probability of selecting a teenage boys whose cholesterol level is more than 225. So we need a probability of X greater than 225. So it's going to be look like this. This is 225, let's say, and greater than, guys, it's going to go to the right. So it's going to be a normal CDF. And let's see. So what would be the lower bound here? The lower bound, guys, do you agree with me? It's going to be the 225. That's the lowest, that's the beginning, just of the area. So I'm going to go to second distribute, normal CDF 225. And can someone tell me what's the upper bound? It's right here.
When 10 million?
10 million, 100 million, whatever you want, make it big. I'll put it there. I'm going to put 10 million. Just put as many zeros as you want. And now, guys, you don't put 0, 1 on the calculator because we're not working with Z, we're working with X. So you just put the mean and the standard deviation. The mean is 170 and the standard deviation is 30 and paste. And that's it. And that should give you the answer. So it's normal CDF 225, 1 million. And if you guys, 1 million is not like a fixed number. If a student want to use billion, you can put a billion. Put a large number. That's what I tell my students. And then what's the mean? 170. And then the standard deviation is 30. And the answer was 0.0334. That was the answer. Now, here's my question to you. That's not what he asked for. He said, if you have 95 boys, how many of them would you expect them to have a cholesterol more than 225? Since we know the probability of a teenage boy having a cholesterol level more than 225, how would you figure out how many of those boys are going to have high cholesterol? You take this probability, guys, and multiply by 95. So if I take this one and multiply by 95, that's the answer. So how many boys do you think? Can't be 3.17. It has to be a whole number. So how many would you say? 3. Exactly. Okay, number 9. Find the area under the standard normal curve to the right of Z equal 1, guys. Let me show you to the right how it's going to look like.
Professor, I have a question.
Mm-hmm.
So you said that we multiply it by 95, right?
Yeah.
Is that's going to be on the exam, right? Obviously.
I cannot tell you. You could have a question like that, but you need to find the probability first. So anytime he asks you how many, if I ask you how many people do you think they're going to have a cholesterol level more than 250? So you find the probability of X more than 250 first, and then you multiply by the total number of people that you have. And to think of this, if I tell you guys I have 30 students in my class, and I think 70% of my students are going to get B or better, how would you figure out how many students are going to get B or better? You take the 70% and multiply by 30. And same thing here. The probability, take the probability and multiply by the total. Okay, to the right of Z equals 1. This is Z equals 1 right here. We need this. I'm trying to do a sketch for you guys so you know exactly what we're doing. So it's going to be normal CDF. Can a student tell me what's the lower bound first of all? It's going to be
negative 10 billion.
No, it can't be. Where is the negative? I don't see any negative. We're starting at what here?
0.
No,
1.
that's the area.
1.
1. It says from to the right of 1. 1 and then a million right here. Then 0, then 1. So that would be, I kind of feel some students are not using the calculator, or a lot of students are not using the, if you're not using the calculator, guys, you have to use the table to find, those answers. So it's going to be a little bit tricky, but with the calculator, as you can see, it's very easy task if you know how to use the formula. So that's the lower, which is 1. Look, lower, start from left to right. This is the shaded area. So always when he says to the right of something, start with that something, guys. Put it there and put that large number after that and put the mean and the standard deviation. Since it's about Z, it always has to be 0 and 1. So you got 0.1587. Okay. Number 10. See, I'm doing a lot of practice here, so you can feel what how this formula is used. Find the area between negative 1.5 and 2.5. That should be easy, guys. This is your lower bound, and this is your upper bound. So it will be what? Normal CDF, negative 1.5, 2.5, 0, and 1. If you have, guys, older calculator, you might not get this screen. So lower is negative 1.5, upper is 2.5, and this is the screen what students will get. Some students are gonna get normal CDF and open parentheses. So if you get this screen, you enter negative 0.5 as a lower bound, 2 comma, separate them with a comma, 2.5 and then a comma, 0, then a comma, and then 1, and then enter. And here's the answer. If he says round to 4 decimal places, you just round it to 4 decimal places. All right, so that's number 10. Okay, guys, 11 is the same. Determine the area under the curve between. Between should be very easy. It's clear what we have a lower bound and upper bound. So you do normal CDF, 0.3, 1.4, comma 0, comma 1. I'll let you find the answer. And now, 12. Assume the random variable x is normally distributed with the mean of 60 and standard deviation of 16. What's the probability of x less than 80? Okay, who can give me? I'm not gonna sketch it now, guys. You're gonna tell me without sketching this one. Less than 80 means 80 and below. What would be the lower bound, guys?
Negative 1 million.
Yeah, you got it. Exactly. So always, guys, here's a hint. Less than, you put this first. And then you put this one next. And you're done. And you put the mean, and then you put the standard deviation. And that's it. Don't put 0, 1 here. That would be wrong because it's about x, not about z. Look, it's x less than 80. So that would be the answer. Let's do it together. Negative 1 million, that's right. 80, 60, 16. For students who don't use calculator, here's what you have to do. You have to change 80 to a z-score and then go to table 5 and figure out, the area from the table. It's a lot of work. I'm trying to make it easier on you guys by using technology in this class. 8944. All right, let's go to the next question. Right, let's see. 13. A physical fitness association is including the mile run in its secondary school fitness. The time for this event for boys in secondary school is known to possess a normal distribution with mean of 450. Okay, so that's the mean, and that's the standard deviation 50. Find the probability that a selected boy can run the mile in less than 3:35. Here's how you show your work, guys. Okay, I'm not gonna sketch it again. So I want a student to tell me what would be the 4 arguments. So what's negative 1 million? We agreed on that. And then the 3:35, and then the 450, guys, and then the 50, and you get the answer. Here's the answer. Second, distribute normal CDF. We don't use normal PDF, guys. It's normal CDF only. Negative 1 million. I'm just gonna change this one to 3:35, and I'm gonna change this to 450 and standard deviation to 50. And here you go. All right, 14. The length of time it takes college students to find a parking spot in the library. It takes more time to read the problem than solving it, if you know what you're doing, guys. to find the library parking lot follows a normal distribution with the mean of 6.5 and a standard deviation of 1. What's the probability of randomly selected college students who will take between 5 and 7.5 minutes? It's always easy when he gives you in between because he gives you the lower bound and the upper bound. You like it like that? X is between 5 and 7.5. And can a student tell me what the 4 arguments are? So what's the lower bound?
5.
5. And then upper bound?
7.
5.
2.5.
And then the mean, and then the standard deviation. And you guys can solve this one. All right. 15. A firm believes, same, it's gonna repeat again. A firm believes the internal rate of return for its proposed investments can be best described by a normal distribution with the mean of 36% and a standard deviation of 3%. What's the probability the internal rate of return of the investment exceeds 42%? Exceeds, guys, means bigger than 42%. Okay. Would one of you be willing to give me the 4 arguments? What's the lower bound? Yes.
You said the 42%.
42%, we start at 42% because that's what we're starting with. And then the sky is the limit. You go what? 1 million. So bigger than, here's what you do with bigger than, guys. You start with the value. So if I tell you guys, I want 10 points or more, that means the minimum is 10 and more, the sky is the limit. You just put 1 million there. And then the mean is what? 36%. And the standard deviation is what? 3%. Now, a question students will ask me, do I need to change this to a decimal? Yeah, change it to a decimal. Or if you don't change it to a decimal, put 42, 36, 3 without the percents. It will work. So let's do this one.
Professor.
Yeah.
So like I usually do this on paper. So like why do we do 1 million? Like for like a
because the
calculator.
okay. This calculator, this is why we do 1 million. Let me show you why. Let me just grab a scrap paper. Yeah, if you do it on a piece by hand, you don't need. Okay, let's say this is 42% and it says bigger. Okay, the calculator program requires. This is the area that we want, bigger than 42%. It goes 42% all the way to the end. We know the normal curve doesn't end from the right and doesn't end from the left. It extends indefinitely and extends indefinitely. So you need, this calculator need a lower bound, which is, we know it's 42%. But look, the upper doesn't end, that keeps going. So that's why we say 1 million or 1 billion, just we say put a large number in there. All right?
Okay, thank you.
This is how we do it, you know, just, so if you do this with normal CDF, watch guys, very lower is 42%. If you can, you put 0.42 million. Mean is 36%, 0.36. So change your percent to a decimal. And then 3%, 0.03, and paste. And here's the answer, 0.0228. All right. So we're done now with probability. Now we're going to do the reverse. We're going to find z-scores given probabilities. And I'm going to keep the calculator handy here because we're going to be using the calculator. How do you find the z-score if they give you the area? He says the area to the left is 0.04. So it's like this, guys. This is the area, which is 0.04. And he wants the z-score. Why did I shade to the left, if you ask me? Because he says it's an area to the left of the curve. So the z-score must be a negative number. Okay, here's how you do it on the calculator. So pay attention if you've been using different methods. You go to second and distribute. You see number 3, what does it say? Inverse norm. That's the inverse of this formula. You just put this one here, okay? And this one, this program wants 3 values from you. It wants the area to the left. It wants the mean and the standard deviation. Well, the area to the left, guys, is 0.04. And since we're working with z, you just keep the 0 and 1 and paste. It's negative 1.75. So z equals inverse norm 0.04, comma 0, comma 1, which is negative 1.75. That's the answer. Okay, now he gives us an area to the right. Find the z-score for which the area under the standard curve to the right is 0.07. Let me sketch it for you guys and show you how we're gonna do this. This is 0.07, and we need this z. Okay, let me get the calculator. Students who are present here, do any of you have, if you go, I'd like you to go to second and distribute an inverse norm. And let me know if some of you have an option that says left, center, right on your calculator.
I do.
Okay.
Yes, I do.
I don't.
Okay, for students who do, it's very easy. Look what you do. So it's what I'm doing right now only for students who have those options. If you don't have them, just wait until I finish with those students. You put the area, which is 0.07. You put the 0, you put the, so for the previous question, guys, you should have put left, but left is selected by default anyway. So now watch what we're gonna do. It's very simple. You put the area, which is 0.07. You put the mean 0, standard deviation. And then your area is what? The area is given to you. It's to the what? To the right. So select right. Can you guys select that and let me know what your answer is?
It's 1.48.
Okay, 1.48. Now, if I do it with this calculator, look what the answer is going to be. It's going to be negative 1.48. Did you notice? Because this calculator, guys, is programmed only for areas to the left. So if you get a negative answer, switch it to positive, but I'm going to show you how I would do it, you know, in one step. Watch. If 7% is the area to the left, but the one who programmed this program right here, he wants the area to the left of the target. So guys, if 7% is the area to the right of the target, how much is the percent to the left of the target? Target is right here. That's the target value. So can someone tell me what would be the remaining percent and the area that's not shaded?
93.
93, excellent. And look, I'm gonna get the same answer now that you got. Watch, 1.48. So will be, so for students who have right, left, it's a lot simpler than what I'm gonna do right now. It will be 1.48. So the ones who have the right, left, center for this question, you should have done this. You put 0.04, you put 0.1 and choose left, because this is a left area. All right.
What if the question doesn't say left or right?
It will.
Because on the assignment right now, mine just says Z and then 0.07.
It can't. It has to say something. You wouldn't know. If it doesn't say, you wouldn't be able to solve this problem. It has to say, and make sure that it's clear on the tests. Yeah. So now we did left, we did right, we're going to do middle. I'm going to show you how to do 18. Determine the two z-scores that separate the middle 87.4%. Now for students who have left, right, center, it's very easy. Just put 0.874 and use center. It's going to give you the two values. But with this calculator here, we're going to have to do some work. So let me show you. So we're processing section 7.2 now, guys. So middle 87.5%, this is the middle 87.5%. Right here, 0.7.4%. Okay. We need this number and we need this number. That's what he wants. They're gonna be the same, guys. One is gonna be positive and one is gonna be negative because this is symmetric. But I'm gonna ask you a question, guys. If 87.4% is this area right here, how much is left for the tails?
12.6.
12.6. Split them up because we have two tails.
6.3.
Very good. Okay, look what you can do, guys, for this one. You go to inverse norm, put the 6.3%, which is 0.063, put comma 0, comma 1, and find me this value. Let's do it. What's the answer, guys? Negative 1.53. Okay, can you guess what this z-score is going to be? If this one is negative 1.53, what do you guess this one is going to be?
1.53.
Yeah, they're symmetric. So this one is 1.53. But for students who have middle right center, look what you do. You go second inverse norm, you put 0.87, whatever it was, 874. You choose 0, you choose 1, you choose center, and it will give you the two answers. That's the beauty of this program. All right, 19. Assume a random variable x is normally distributed with a mean of 50 and standard deviation is 12. Find the 24th percentile. 24th percentile, guys, means area to the left is 24%. So you just go to inverse norm and put this area. When it is to the left, you just put it as is. And don't put 0 and 1 here because he gives me a mean and standard deviation. So I need the x value, not a z-score here. So I'll put 50 and I'll put what? 12. For students who have left, right, center, make sure to choose left right there because this is a left area. So percentile, guys, learn it. Make sure to understand. It's when I say a student is at the 80th percentile means 80% of the students are below you. Below you means to the left. So let's see what the answer would be. If I go here, 0.24, and if I put x, mean is 50, and standard deviation is 12, and 41.5. All right, that's number 19. We're gonna go now to 20. A physical fitness association is including the mile run in its secondary school fitness test. The time for this event for boys in secondary school is known to possess a normal distribution with the mean of 440 and a standard deviation. So I will just underline those values. That's the mean and that's the standard deviation. The fitness association wants to recognize the fastest 10% of the boys with certificate of recognition. What time would the boys need to beat in order to earn the certificate? So who will be eligible for the 10%? That's the normal curve. That's the mean, which is what, 440 seconds. And the standard deviation is 50 seconds. So the fastest 10%, guys, what do you think it's going to be, an area to the right or to the left?
To the left,
Right.
Why to the left? Why not to the right?
because it's marathon or
Aha, very good.
the smallest is the good one.
Exactly. Be honest with you guys. Every time I put this question on the test, 50% of the students make the mistake by shading 10% on the right. You think fastest means biggest. Well, you know, if you're faster, that means you're gonna finish in less time. And this is about time to take, you know, to finish, you know, just the run. So in this case, this is a unique case. In the case of marathon, as you mentioned, or running or walking, faster means you finish in less time, and less time means an area to the left. So you are correct. This time is going to be 10%, right here. And we need this x, guys. X. A will be inverse norm. You put the area to the left, which is 0.10, and then 440, and then 50. And you just find the answer using the calculator. Here's how you find the answer. Clear. Second, distribute inverse norm. 440 and then 50. 376 seconds. So if you do 376 seconds or less, you'll be qualified to get the certificate. And this is what I tell students. I tell students, even if you made a mistake and you put the 10% on the right, then the area on the left will be 0.90. The answer that you're going to get is not going to make sense. It's 504 seconds. How could a student be the fastest, one of the top runners, and it takes them more than the average time it takes an average students to do the run? The average is 440. You're going way above average to finish a run, and you say you're the fastest, one of the top 10%. That doesn't add, so that's why it should be this. See, less time. Here, more time. If you put 10% here, it will be asking you about the slowest 10%, not the fastest. Okay.
Mr. Bezzi,
Yeah. Go
will you
ahead.
tell us on the test whether what place to round up to?
Oh, definitely. Yeah. Assuming that all salary of elementary school teacher, that should be an easy one. In the United States are normally distributed with the mean of 37 and standard deviation 5,000. What's the cutoff salary for teachers in the bottom 10%? Remember, guys, when he gives you a percent, that means he's giving you a probability and he wants you to go backward and find X. Bottom 10%, we don't disagree. It's on the left. So it's 0.10 on the left. Bottom salary means low salary. Low salary means on the left. And just put the mean and the standard deviation, guys. Standard deviation is 5,000. Okay, 22, just skip this one. It's a little bit irrelevant questions about the mean. Don't worry about it. And now I'm gonna go to section 8.1. About the working with samples now, not working with one individual, working with samples. Determine mu of x bar and sigma of x bar from the given parameters of the population and sample size. Round to your answer to the nearest thousands. Okay, you know, guys, when you have a normal population X and you select samples of size n, here it's 22, you're gonna get this population. It has the same mean as the previous population. But what do you notice about the opening of the curve, guys? This is wide here. This is narrow. When you work with sample means with X bar, you get a smaller standard deviation, which is a good thing. So mean of X bar, guys, it's always the mean, which is 28. And sigma of X bar is original standard deviation divided by square root of n. I mean, you gotta find a use for this number to find the standard deviation. So sigma will be 8 divided by square root of 22. And to do this, you just do it on the home screen. 8 divided by, And here's how you find the square root. You just go second and key 22. Okay, well, he wants to the nearest thousands, mean 3 decimal places. So what would that be, guys? 1.7, 0, and what? And 6. So, and this standard deviation of the samples, guys, has another name in your book, standard error of the mean. So if I ask you to find the standard error of the mean, you just take the original standard deviation, population standard deviation divided by square root of the sample size. Those formulas will be provided to you as well. So the mean will be the same as the mean. It's exactly same mean, look, but you have a narrower curve, means a smaller standard deviation.
Professor, since you're recording this right now, so are you gonna make it available for other students to watch, or that we can
Yeah, I
watch
will
again?
send it. I will send it to all.
Okay, thank you.
24. What's the value of this? Is for X bar. Okay, can a student tell me what's the mean here? The mean is the value in the center.
So
8.
8.
8. What's the standard deviation of the sample mean?
0.04.
Exactly, it's a difference between these two or these two. Done. 25. Same question as before, you're gonna see. Number of violent crimes committed and they possess a distribution with a mean of 2.2 and standard deviation of 6. Now we're working with a sample of size 100. So N is 100. And the mean number of crimes from the sample was calculated. Describe the sample and distribution of the sample means. So it will be a normal distribution. The new distribution will be a normal distribution, but will be a narrower curve. We need the mean and we need the standard deviation. The mean will be the same as the mean, the original mean, which is 2.2. And the standard deviation, guys, will be 6, but you have to divide it by square root of 100, which is 6 over 10, which is 0.6. Done. Number 9, 26. The amount of time employees of a telecommunication company have worked for the company are normally distributed with a mean of 5.4 and standard deviation of 2.2. Random sample of size 12 are drawn from the population. The mean of each sample is determined. And the question, guys, we want mu of X bar and sigma of X bar. Same question as before. So the mean will be the same as the mean, which is 5.4. And the standard error of the mean, or sigma, will be 2.1 divided by square root of 12. You're gonna see, guys, how we work questions with find the probabilities when we have samples, not just one item, and you just do this one. Okay, now I'm gonna show you some good application of section 8.1, very good application. And that's the difference between chapter 8 and chapter 7, right here. It's gonna happen right here. Assume that the salary of elementary school teachers in the United States are normally distributed with a mean of 32,000 and a standard deviation of 3,000. Okay. If 100 teachers are randomly selected, so N is 100, guys. What's the probability that their mean salary is greater than 32,500? He wants the probability of the mean. The mean, guys, is not X. We have a symbol for it. It's X bar greater than 32,500. Okay, that will be normal CDF. I told you, this is the only formula for probability. Can a students give me the lower bound here? What would be the lower bound?
32,500.
Yeah, 32,500. What's the upper bound?
Million.
Million, billion, just put large numbers. What's the mean?
32,000.
Okay. What's the standard deviation?
3,000.
Wrong.
3000 divide 100.
Divided
Square root
by. This is
Equal-
the difference, guys. If you put 3000, you only put 3000 when you work with one item. Here, I'm not working with one item. I'm working with a sample of size 100. And the question is not about one individual, it's about the average of the 100. When the question has this word, guys, probability of the mean, you cannot use the original standard deviation. You have to use the new standard deviation from the samples. Look, guys. So look, you want to make it work, you do this. And now it's going to work. Otherwise, you will get the wrong answer. So let me just do this for you. Second, distribute normal CDF. So we got 32,500. You get 1,000,000. You get 32,000. And then 3,000 divided by 10, square root of 100 is 10, there will be 300. And that's it. Now I'm gonna get perfect answer. 0.0478. All right, so go to the next one. Let's show you, we're gonna do the same work now. The average score of all golfers for a particular course has a mean of 75 and a standard deviation of 4.5. Suppose 81 golfers, so N, guys, is giving you a sample size. Is giving you the mean 75 and is giving you the standard deviation 4.5. What's the probability that their average score, average means mean, of the 81 golfers exceeds 76? So it's like this, guys, greater than 76. So would you agree with me if I put 76 to begin with, then 1,000,000, then 75, and look what I'm gonna do here, guys. 4.5 divided by square root of 81. When it is about X bar, we divide by the sample size. Once I give you a sample size, be sure that the question is going to be about X bar, not X. All right. Okay. The amount of money collected by a snack bar at a large university has been recorded daily for the past 5 years. Records indicate that the mean daily amount collected is 4,000. With a standard deviation of 4,500. The distribution is skewed to the right due to several high volume days, including football game days. Suppose that 100 days were randomly selected, so N is 100. It's not a probability question, it just wants you to describe how the samples, the sampling distribution would look like. Which of the following describe the sampling distribution? Probably there were choices here, but I removed them. But look, this is how it will look like. It will look normal with a smaller standard deviation. This is what X bar is. And all you need to do is find mu of X bar, which is the same, 4,000. But sigma of X bar, guys, is not going to be the same. It's going to be 4,500 divided by,
Professor, I think it's 450.
oh, 450, you are correct. Divided by square root of 100. So sigma of X bar, guys, will be 450 divided by 10, which is 45. This is why we like to work with samples, guys, because samples give us a smaller standard deviation. Standard deviation large means there's a lot of variation in the data set. But when the standard deviation is small, there is not a lot of variation in the set. If I tell you guys, your score in the next test is going to be between 40 and 80, there is no way that you can tell whether you're going to pass the test, what score you're going to get. There's a lot of variation. Here, the standard deviation will be very large. But if I tell you guys, I think your score on the next test is going to be between 70 and 77. The standard deviation is very small here because all the values are close together. It's always better. I would prefer to work with 45 standard deviation rather than working with a standard deviation of 450. 30. The length of pregnancy are normally distributed with the mean of 264 and a standard deviation of 15. So this is the last question in section 8.1. If 36 women are randomly selected, so it's going to be about X bar, guys. I'm giving you a sample size. What's the probability that their mean pregnancy is between 264 and 266? So you start with this. You put 264 first, and you put X bar between. Okay, now I want one of you to tell me what would be the 4 arguments. So what would be the lower bound, guys?
2.64.
264. Upper bound.
266.
Mean.
264.
Standard deviation.
15.
That's it.
Divided by
Square root. Don't forget that. You forget it, guys, you get the wrong answer. Definitely. So that ends the discussion for chapter 7, section 7.1, 7.2, and 8.1. What I'm gonna do, guys, I'm gonna stop the recording and do another recording so that will be faster for me to upload the videos.